Ouais.
Qu'est-ce que tu as fait?
Non, j'ai fait.
Okay, so how do we make these? How do we produce the information needed by this multi to work? So essentially, what we'll show you is all the information needed for running WaveWatch, and how we start from some basic data, and how you actually can update and modify these grids to cut out some pieces of the domain you don't want and all that stuff. All right, so typically what WaveWatch needs to run is our three grids. One is the bathymetry. So yesterday, we first ran this very simple propagation case where the bathymetry was constant, which is hard-coded inside of the w3grid.inp. What you do rather in general is that you have to read a file with the depths, and you need to provide that bathymetry file. Then there is a masking grid for land, sea, and boundary recognitions, which is optional for a single grid that you really need to provide for the multi-grid. And that essentially defines the land and sea, the excluded points, and the boundary conditions, how the grid communicates. And then there is a grid for the obstructions due to subgrid islands. And then this is typically to take into account the fact that some of the energy is blocked. And of course, Lorenzo has another option for doing this through a source term to a poster, but that's another interesting way to do this. And if you do that by hand, that can be a lot of work, especially to define the boundary conditions and the communication between the grids. And so to facilitate that, NCEP folks and Arun Chawla has been putting together this hidden tools. So first, it starts from a bathymetry grid, and so I think what we use here, I think it would be eTopo1 or something like that. But you can provide your data with the same format and read it in. Then you create the land-sea mask. So typically from that thing, it's very easy to say what is land and what is sea. Okay, but then you also want to cut out, maybe only do the Atlantic. You want to cut out this part of the Pacific. Because there's there's some simple ways to do that with the tool, and that was this red part masked out here. Step 4, then you build the obstruction grid. So this is here the fraction of the grid blocked by the island, and you can see there's a bit of red here. That's all the Bahamas. There's all the small islands around Bahamas, and some small island in the West Indies also. And then step 5, you identify the node for exchanging boundary information, and that's when you use multi-grid. So typically, if you want to cut it out somewhere, you just specify which are the forcing boundary points. So yeah, I think together with the package, I think is included eTopo1 or eTopo2, and to do the subgrid island thing, it's including the shoreline database from University of Hawaii. It's fairly coarse for Europe, and it's not so super high quality, but at least you can work with it. And this is what we'll do this afternoon. For the matching with the triangles, we'll also we'll start with that, or if you have your own coastline, you can read it in. And if you want to replace eTopo1 and eTopo2 by some other bathymetry data, it's not that difficult to do. You just have to change one reading script in MATLAB for that. So what happens there? So starting from these bathymetry data, it just interpolates that on a regular grid. Then it extracts the boundary from this shoreline database and does all that stuff for you. So you just have to specify the area you want to do and the resolution, and everything will be done. So that's the idea. So you go from the high resolution grid, it will get you latitude and depth. And the boundary will be used to define the blocking from the small islands. And this is all explained in details. There's a couple papers by Arun Chawla about that. And the result of this is, in the end, the bathymetry file and the masking file for the land and sea, and then the obstructions SX and XY for the subgrid islands. So at the end, you get these 3 files: depths, mask, and subgrid islands. So the way it's together, so you have a GridGen parent directory, then the data folder with all the data, and then the scripts are in bin, and then there's a folder with called examples, and typically you will run GridGen in that folder, and you will generate some data here. There's not, essentially you can go back to the Arun Kala paper and you get all the details. So I'm not going to spend too much time on that. There's a bit of a choice for the shoreline choice, because this shoreline business with the subgrid islands can take some time. So if you're just doing tests, you may want to use, instead of using the full resolution shoreline, which may be less than 100 meter spacing on the coast, you may want to use something intermediate to just try how it goes. And then when you're happy, you just run into the full and you go back for lunch. You go for lunch and you come back, you have your grid. That's typically what happens. And so the basic idea is that so you have these polygons that define the island, and that's your grid cell, and you want to count for how much so there's some feeding to be done to go around the polygons and figure out what's coming out in your cell, and so this. Arun Kala has been doing that. So there used to be some bugs in the first version of GridGen. He fixed a few of these. So if you find some, just send an email to Arun, and he'll be happy to look at it. I'm sure he'll be so happy, but he will look at it. And that's it. So the mask is, so first thing which is done is to you define a depth cutoff, which is this. When I was mentioning yesterday to you this issue with the depth, so you have a cutoff depth which tells you if something can be dry, or if it will be always dry, or if it can be wet. So based on this depth threshold, typically you can put it at 10 meters above the mean sea level. So you're not doing tsunamis, or you're hoping to be safe that high. And so that will basically take all the points that are high to be dry points. And then the other steps is just cutting out some pieces, so you don't have the big lakes or the Caspian Sea or some other pieces of body of waters. You can just cut them out with some polygons. And right, so that's some example of how you go from the red is wet, the blue is dry, and the white is some wet that has been switched to dry, depending on some other criteria. So that's what it would look like for Hawaii. So you have the depth at 0.1 degree and the depth of the mask here. Okay, so yeah, I think this is, in order to make it faster, what he's been doing is actually to split the polygons into smaller pieces. For example, the biggest polygon in the Hawaii database is its Eurasian Africa polygons, just one big piece of coastline. And so if you're working on this big polygon with many, many points, that can take some time. So you just take that and split it to smaller pieces, and then works with these pieces separately to make it faster. This is also some example to show how you go from water and land to something in which you, so here, for example, you see this one small piece of the Sea of Cortez is joined, and so he has an algorithm to cut out the small pieces of water that are different from the big ocean, and here also to identify the Gulf of Mexico, a separate piece of water, and then you can choose to include this in the calculation or remove it. And that's basically it. So I'm not going to go into more details. And yeah, and then once you have your mask, one thing we will do also is, so the mask is this map of wet or dry points. What you may want to do is cut out a piece in that mask. And so there's a special script in MATLAB for doing this. It's called ModMask. And so you can do it by either reading in the polygon information, and we have a version which you can just click on the map and to select the area you want to do. So for example, in some of our grids, we're only doing the West Indies here, so we just put the polygons around here and cut out everything else. So here, for example, we're cutting here. And so when you do this, the tool will identify that these points along the edge must be boundary point conditions for wave watch. So that's the point where you need to have information coming from the larger scale grid, and so the MATLAB tool will do that for you to detect all these points where you want to have the boundary condition. And yeah, and then the overlapping. Okay, that's grid 1, grid 2. So that's one case in which you have two grids. One goes further north, and the other one doesn't go so far north. That's the story with the different time steps. And if you put them together, you get that. All right. So you can use that to do this, and that's it. So basically, it will be easier when you actually run it. But what we need to define in the end, all these three maps, so the symmetry, the mask, which defines if it's water or not water, and the subgrid island blockade.